Okay, one of the questions that came up in class was on derivative worksheet 1, problem number 38, and that was on page 103 in the textbook. So let's take a look at that. This is the problem, and what we're told to do is find a line that's tangent to the graph of f and parallel to this line here. Now, if we're going to find something that's parallel, we're going to have to find the derivative here, find the slope here, set them equal to each other, and then find the x and y values. Okay, so let's get started. I'm going to put a heading on our paper first. Derivative worksheet 1. Problem 38 on page 103. Now the problem is f of x equals 1 over the square root of x minus 1, and the equation we're given is x plus 2y plus 7 equals 0. So let's start by finding this derivative. Now we're going to have to use the limit process, which is a little cumbersome, but that's what we have at this point. Delta x goes to 0, and this would be 1 over the square root of x plus delta x minus 1 minus 1 over the square root of x minus 1, all of that over delta x. Well, the way we're going to start is by cleaning up this numerator, and to do that we need to find a common denominator. Now, one quick way of finding the common denominator is to take this denominator times that numerator, then this denominator times that numerator, and the denominator becomes the product of the two. So let's write this as the limit as delta x goes to 0, and when we do our multiplication we get x minus 1 minus the square root of x plus delta x minus 1, and all of this is over the product of those two denominators. X plus delta x minus 1 times the square root of x minus 1. Now we're dividing by this product, and we're dividing by delta x, so I can pull that delta x up here. Now that doesn't look much better, but if we multiply by a conjugate for the numerator, we can eliminate the radicals without introducing a middle term. So this will just be the square root of x minus 1 plus the square root of x plus delta x minus 1 over x minus 1 plus the square root of x plus delta x minus 1. Now as long as this denominator is not 0, we're just multiplying by 1, so that's acceptable there. Now this will clean up. The limit as delta x goes to 0 of x minus 1 minus x plus delta x minus 1 all over delta x times the square root of x plus delta x minus 1 times the square root of x minus 1 times the square root of x minus 1 plus the square root of x plus delta x minus 1. Okay. Now this will clean up. The x's disappear. The 1's disappear. Negative 1 minus negative 1 becomes negative 1 plus 1, which is 0. So now we have the limit as delta x goes to 0. Let's move up a little bit. Of negative delta x over all of this, delta x square root of x plus delta x minus 1 square root of x minus 1 times the square root of x minus 1 plus the square root of x plus delta x minus 1. Now this cancels out, leaving me with a -1 in the numerator. Now let's take the limit at the same time. When delta x goes to 0, this disappears, and so does that. Now since I've taken my limit, I no longer have to write the limit as delta x goes to 0. This just becomes -1 rather, over the square root of x minus 1 times the square root of x minus 1. And in here I've got 2 of these square roots of x minus 1, so this is 2 square roots of x minus 1. And that's looking a lot better. I can clean it up a little bit more. So this will be -1. I'm going to pull the 2 to the front. Then I have the square root of -1 times the square root of -1 times the square root of -1. So I'm going to write this as x minus 1 cubed, since I have 3 of them. And then I have to take the square root, so I get that. And this is what my f prime of x is. Now let's go back to the line we're given. We're given the line x plus 2y plus 7 equals 0. That means 2y equals -x minus 7, and y is equal to -1/2 x minus 7 over 2. So the slope of this line is just -1/2. Now a derivative is a slope at a point, a rate of change at a point, and if these things are going to be parallel, then this derivative has to have that same value here. So let's set f prime of x equal to -1/2, and that means that -1 over 2 x minus 1 to the 3/2 is equal to -1/2. If we cross multiply, we get -2 is equal to -2 x minus 1 to the 3/2. Dividing by -2, we see that 1 is equal to x minus 1 to the 3/2. But I need x, so I need to eliminate this exponent. If I raise it to the reciprocal of that, do the same on both sides. Now 1 to the 2/3 is still 1, but on this side I get x minus 1. Adding 1 to each side, I see that x is equal to 2. So I have my x value at the point. Now I need to find the y value to identify the point, so I need to evaluate f of 2. So I'm going to take 2 and plug it back into the original equation. This x comes out and I put a 2 in there. And I get f of 2 equals 1 over the square root of 2 minus 1, which is 1 over the square root of 1, which is just 1. So my point becomes 2 and 1. My slope is m equals -1/2. Now I need to find the equation of the line that has this slope and goes through that point. Now parallel lines have the same slope, that's why I'm using -1/2. So let me recap that on this sheet. I have the slope is equal to -1/2. My point is 2 and 1, so I'm going to use the point slope equation. So I have y minus y1 equals m times x minus x1. y1 is 1, so y minus 1 equals the slope m, which is -1/2, times x minus x1, which is 2. So y minus 1 equals -1/2 x plus 1. Adding 1 to each side, I see that y is equal to -1/2 x plus 2. And that's the equation we're looking for.